Hello everyone and welcome to this cloud coaching session. This session is part of the Modern Data Platform series and today I shall be talking about the public sector. I'll also walk you through a use case related to public sector. My name is Rakesh Chhoria. I am part of the EMEA Analytics Specialist team and I live in Bangalore, India. Today's agenda would be, we will talk about public sector in general and some of the common use cases that we see in the various domains of public sector. And then we will look at one of the use cases that is around tax filing analysis in little more details. Public sector is a very important sector that primarily works to improve the lives, experience and care of the citizens. As its work and policies impact the citizens, it becomes imperative for this sector to become data-driven for delivering its services, policy formulations. By harnessing data analytics, they can gain actionable insights that help optimize resource allocation, streamline processes, and improve service delivery. Public sector caters to a wide range of domains, starting from education to social services to emergency management, law and order, and citizen engagement. Let's look at some of the common use cases that are spread across these domains. As you can see, for education, we see that there are use cases around recruitment, training and personal development, personalized learning, early warning and engagement, outcome prediction, to social services where we say we need to do risk management, resource planning, population analytics, performance monitoring and accountability. In the domain of financial management, we see that reducing fraud, improving revenue collections, data-driven planning and budgeting, procurement optimization, these are some of the very important and commonly found use cases. For environmental and urban planning, we see that mobility and transportation, traffic forecasting, energy efficiency, land use planning are again some of the very important use cases. Coming to the other domains where we have emergency management, again, early warning systems, live data analysis, emergency deployment data platform. Again, these are some of the very important use cases in today's day and age. And on towards criminal justice and law and order, we have predictive policing and crime prevention, predictive resourcing related use cases, real-time incident monitoring use case. On the infrastructure management and resource planning, again, we have infrastructure performance monitoring, supply chain and logistics planning and optimization, risk assessment and resilience planning. These are some of the use cases. And finally, for citizen engagement, again, citizens are at the heart of everything that public sector does. So some new use cases are also coming up like Citizen 360, demographic and social inclusion analysis, citizen analytics and open data, even community engagement, so on and so forth. Now, in this session today, we will look at one of the use cases that is around tax filing analysis. So here at a high level, the use case is as follows. We have assumed that we are looking at the tax filings of customers who primarily have rental income as their source of income. So first we would like to understand the income, okay, the tax filings of these particular taxpayers. Then for this particular category, which is rental income, it is observed that certain expenses can be claimed as exemptions from the gross rental income to arrive at a net taxable rental income. Now for this demo, we have assumed some exemptions. These are the insurance that the taxpayer pays, the agent fees, the land rent, the repairs that they have to undertake for the properties, right, that they have, that they own, then the loan interest amount and electricity. Now, as part of these tax filings, we will analyze the exemptions amount being claimed, and then we will also look at how we can use the capabilities of modern data platform and see to build and apply a machine learning model to predict the exemptions amount and identify which tax filings need to be analyzed further. So now that we have the context of the use case, let's dive into the demo. Now, as part of the demo, as you can see, we have logged into the Oracle Analytics Cloud environment, and we will first look at the tax collections data. Now here the idea is to look at what is the actual revenue and how is it performing with respect to the target. So the overall tax revenue collection is very good. We are almost achieving 99.34%, 100% of the target achieved. But then this tax revenue is actually divided into different subcategories. So we have something called as tax category of business rates, then capital taxes, corporation tax, council tax, fuel duty, income tax, national insurance contributions, other receipts, other taxes, tobacco and alcohol duties, value added tax. So now at each of these category level, if we see, we are seeing that except for income tax, where we just have achieved 91% of the target, all of the others have been either 100% or more than 100% of the target achieved. So there is definitely something that is happening at this for this particular tax category called income tax. So now let's look at little more details on income tax category. Now this income tax category is primarily divided into 5 subcategories: income from employment, income from investments, income from property rentals, private and state pensions, and self-employment. Now clearly we see that almost all of the categories are below 100% when it comes to the target. Okay, and one of the categories is actually performing very badly, which is income from property rentals. We see that we have achieved only 63.6% of the target. Now, one of the feature that you see here with this colors on the table visualization is what we call as conditional formatting. Now, how we can do this? Now, to do the conditional formatting, what we have to do is we have to define rules. Okay, so in this case, we have done a rule called as variance in income tax. So we are measuring the variance in income tax subcategory, where we will take 3 different colors to identify. So if the variance is more than 1.05, so meaning if the income tax subcategory, a particular subcategory achieves more than 105% of the target, show it in green. If it is between 90 and 105%, show it in orange or orange. And then if it is less than 90%, show it in red. Now, once we apply this particular conditional formatting rule, we can see that most of the subcategories are in orange color and one of the categories is in red color. So this conditional formatting is again a very good way to highlight certain data points which are like, say, anomalies or outliers in a table visualization, right? Table or pivot visualization, so that as a user, your attention is taken to that particular data point and then you can do further analysis. Okay, so now that we have identified that the income from property rentals tax subcategory under income tax is where we have achieved only 63% of the target. So now let's look at some more details of what is happening in this particular subcategory. So for this, as an analyst, what you would like to do is you would like to see what is this particular tax subcategory, what is the kind of data that we have. Okay, now coming to the rental income, as I had mentioned at the starting of the use case, right, that rental income also allows you to claim some exemptions. Okay, so here what as an analyst I have done is I have taken the top 500 taxpayers data whose primary income is rental income. Okay, so as you can see, the average gross annual income is around 9.12 million. The net annual income works out to be 6.5 million. The average tax paid is 1.92 million. So average tax percentage works out to be 21.08%. And the expenses claimed as a percentage of income for exemption is 28.77%. So this is at an aggregate average level for all the top 500 taxpayers. Now, if you look at the split, we have these taxpayers from various regions. So we have some from Liverpool, some from Manchester, some from Leeds and Nottingham, so on and so forth. Okay. So moving ahead, clearly we can see that from this particular dashboard, expenses as a percentage of income claimed for exemptions appears to be very high. So let's look at the details, some of the details on these expenses. So again, as I had mentioned, we have taken a sample data set of 500 top taxpayers, right? Expense as a percentage is 28.77. Now what you see here as segments is actually a new column that we have defined in the data set using the data preparation capability, where we have binned it based on the gross annual income. Okay, so we have created 5 different segments based on the gross annual rental income. So across segments, what we see is more or less it's in line that the expenses claimed range between 26.7% to 28.59% and 29.13% for segment 2. Now, this visualization here is what we call as a tree diagram. Okay, so here we can see the flow of the income. So from gross annual income, what are the different categories and where the income, gross annual incomes journey from being gross annual income to the net taxable income, and then also what is the tax paid to the total income post tax and expenses. So clearly we see that the gross annual income is divided into two categories: exemptions that are claimed for exemption, then you have the net annual income. Now, as part of expenses, we have agent fees, electricity, insurance, land rent, loan interest, and repairs. Now, these are the percentage of gross annual income that has been claimed as expense for each of these categories. So for agent fees, it's 2.65%. For electricity is 3.5%. Insurance is 0.86%. Land rent is 0.51%. Loan interest is 6.4% and repairs is 13.56%. Now the total tax paid comes to 21.08%. So as a result, the total income post tax and expenses works out to be 51.44%. Now this gives us a very good idea of what are the different exemptions that are being claimed, and clearly we can see that repairs as a percentage of expense is pretty high. Correct? So out of the 28.77%, around 14%, 13.5% is actually being claimed as repairs. So almost half of the expenses that are being claimed are towards these repairs. So now let's look at little more details on what are these data around repairs. So here we see that repairs claimed as a percentage was actually 14.85%. So actually the taxpayers had claimed repairs amount which amounted to 14.85%. But as a percentage approved were 13.56%. So in amount terms, it works out to be like 677 million were claimed, whereas 618 million were approved, resulting in an approval percentage of 91.31. Now that we have these top 500 taxpayers, we would also like to see how are each individual taxpayer claiming these repairs, right? So we see that for the top 10 taxpayers that you see here, we see that the amount percentage is as high as 28.5%. Now this is 28.5% of gross annual income claimed as repairs, not just expenses. Okay, it's just one part, which is repairs. Then 26.3, 24.90, 94, so on and so forth. And for the taxpayers with lowest claim as a percentage of expenses to gross annual income is as low as 4%, in fact 3.94%. So now this actually gives us a very wide band. So the repairs as a percentage of gross annual income claimed as expenses is between 4 and 28.5%. Now that's a big band, right? So we would like to do some more analysis on this and see. So I'll try to drill down into the particular details of these taxpayers to look at some historical data. So how this particular taxpayer has been claiming repairs over a period of time. So here we see that for this year it was 24.29, then 21.8. Only for the COVID year it was around 7.7%, and for 2019 year it was 20.67%. So here we can clearly see that this particular taxpayer has been claiming repairs as a percentage of expenses very high. So it has been always about 20%, barring the 1 year where it was COVID year. Okay. Now this way, if we can do analysis further, we can definitely see how is the pattern. Now let's say look for one more taxpayer, where if I have to look at the details of this particular taxpayer, again we see that the amounts are more or less similar. Okay. Now what we will do is, this way we can do analysis and try and identify which are the taxpayers which are claiming very high amount. Now this is actually a very tedious process, right? So if you have to open each and every taxpayer's filings, go through these numbers manually, it's actually a lot of time. And currently the system is doing it, where the tax department is doing it, and clearly we see that because of this manual intervention where they have to check each and every tax filing, we see that the time to process a particular tax file is going up. So in this case of data set that we have taken of 500 taxpayers, almost 213 files had to be opened for revision. So the revision percent works out to be 42.6%. And as you can see here, the red and green bars, the green bars are the ones where the files were submitted and processed within the targeted time. Okay. Whereas as we move on, we see that for many of these tax filings, they had to be open for revision, then new expenses, or say they had to provide supporting documents, and then the tax department would either agree or ask for more information. So all of this is leading to actually an increase in tax file processing. So this is another burden on the department to process these files. Now, so as you can see, with the analysis that we have done on this particular category, tax subcategory of income from property rentals, we clearly see two things. One is that there are various types of expenses that are allowed as deductions, okay, and repairs is one of such expense that actually is pretty high. And second is, if we start looking at manually, it will take a lot of time for the people in the department to actually process these files. So how we can address these two problems together? So this is where, using the new AI and ML capabilities of modern data platform, we can actually think about building a machine learning model using the historical data that we have of these tax filers, and then we can use it to predict actually the suggested repairs amount. So in this case, we would like to focus on the repairs as expenses. So using the historical data where we have data of repairs claimed and approved, right? We can use that and try to build a machine learning model. Okay. So now I'll walk you through the steps of how we can build a machine learning model. So for this, we will use a feature of data flow. Okay. So here, so the first step would be actually to build a machine learning model for prediction. Okay. So for this, what I've done is, of the top 500 taxpayers data, I have taken around 80% of the records as training data set. So I'll use this data set to actually train and build a machine learning model. So my data set has all of these attributes where I have the tax ID, the region, postal code, the number of houses that each of these taxpayer owns, and then what is the gross rental income, and what are the repairs that have been approved. Okay. So in this case, again, I am selecting all of these columns, but in practical use cases, say you might have data sets with a large number of columns, right? Then based on the domain knowledge that you have, you can actually filter out and select few of the columns that you think are necessary to build a machine learning model, which you think are important, okay, to build a machine learning model. The next step would be, we would like to do a numeric prediction, because we want this machine learning model to predict the repairs amount. So for a certain gross rental income, for a certain number of houses, for a particular region, right? What could be the suggested repair amount that this machine learning model would give? So for this, we will use numeric prediction. Now again, out of the box, the system Oracle Analytics Cloud provides 4 different machine learning algorithms. For our demo purpose, we have used linear regression. Now the second important parameter that we need to provide is the target. So in our case, we are building a machine learning model to predict the repairs amount. So we will select the column repairs. Now rest of the parameters, you can leave them as default for now. Okay. You just give a name to this particular machine learning model, save and run the data flow. Now once the data flow is run, a machine learning model is now ready for consumption. Now in this case, what you see is we had to build a machine learning model for numeric prediction. Whereas Oracle Analytics Cloud also provides you options to build machine learning models for classification problems, be it binary or multi-classification, or in some cases, if you want to do some unsupervised machine learning, there is also support for clustering model building. Now that we have built the machine learning model, let's go and check the machine learning model once. So for this, we will navigate to the tab machine learning. So here you can see that I have the machine learning model here available. So I'll just look at the quality of this particular model. So this is the model that we have built. Okay. So this is the quality of the model. This is how the binning has been done over the data range. Okay, this is the mean absolute error, median absolute error, so on and so forth, other statistics. Now, based on the values of these statistics, you can decide whether a particular model is a good model with a decent accuracy to use it, or you can go back to the data flow and tune the parameters a little to improve the ML model's accuracy. Okay. Now, for our demo purpose, let's assume that this model is okay and ready to be used for testing. Now, what we will do is, again, we will build a new data flow where we will use the data set that we have of the taxpayers count. Okay. So this is the data set that we are using for prediction. Okay. For prediction. Now what we will do is we will apply the newly built machine learning model. So in this case, we will just select the model that we need to build. And then this model is actually creating one new column called as predicted value. So I have renamed this column to suggested repairs amount. Rest of the parameters you can leave it by default. Now in my case, the data set actually has all of the columns same. In your case, suppose if you have the machine learning model that was built using a training data set where the column names are different from, say, the data set that you're using for prediction, then you can actually map them also here. Okay, you can map them and overwrite. Okay, once we have this task configured of apply model, this particular data flow will actually create a new data set, okay, which will have the predicted or suggested repairs amount. So we give a name to this particular data set. Now this data set will have these columns. Okay, we can specify which is an attribute, which is a measure, and what kind of aggregation we want to use. Once we again save and run this data flow, upon successful completion of this data flow, you will actually have a new data set created with the suggested repairs amount. So now let's go back to the workbook that we have here. So from there, I'll try to show you the So I have already added the data set here to this particular workflow. And here, this is how you see the data now. So we have the data of the taxpayer and what were the repairs that this particular taxpayer had claimed as part of the filing, and what is the suggested repairs amount. Okay. Now again, I have used the feature of conditional formatting. So in this case, what I have done is I have used the option of, because it's a suggested repairs amount, and machine learning model building, as you know, is an iterative process, right? So to give some leeway for threshold and variance, for demo purposes, I have used, say, a variance of 30%. Okay. So I'll show you what I mean by this variance of 30%. So what I have done is actually I have created a rule where I'll say between the repairs claimed and the repairs suggested. Okay. If it is less than 100%, if the repairs claimed is less than 100% of the suggested repairs amount, then I'll highlight it as green. And if it is between 100 and 130%, so the repairs claimed is between 100 and 130% of the suggested repairs amount, then I'll have this orange. And if it is greater than or equal to 130%, then I'll have it in red. So now what happens is, once I apply this conditional formatting rule, you can clearly see that there are few tax files here where the variance is more than 30%. Okay. So these are definitely the tax files that definitely need to be opened for revision, because the expense repairs as expenses claimed is much higher than even the predictions that the machine learning model has given. Now, based on iterations of machine learning model building, you can actually iterate it and maybe bring down the variance from, say, 30% to 25% or 20%, even 10%, based on the model's accuracy and the kind of data that you feed it into the ML model building process. Okay. So now, as you can see here, we have started with a use case where we initially analyze the KPIs of tax collections. Okay. And we have seen one issue with one of the particular tax categories, which is income tax. When we drill down and we drill down further, we see that there is one particular subcategory under income tax, which is income from property rentals, where we have missed the target. We have only achieved 63.6% of the target. And then we started doing the analysis of the data, okay, where we try to get into more details about the type of expenses that are getting claimed, okay, and we identify an issue with one of the expenses types, which is repairs, and then we can also use the machine learning model building capabilities to actually predict a suggested repairs amount, and then you apply it to the existing tax files, and then we can actually use the suggested repairs amount to see which tax filings need to be opened and which are okay. So this definitely helps to speed up the tax filing processing exercise as a whole. And again, with the improvement in machine learning model building, which you will do in iteration based on the various data set that you will provide, right? Then it also improves the accuracy. So both efficiency as well as identifying the right tax files that need to be opened for further analysis. So this way, actually, even the interaction between the tax department and the tax filing person, right, also improves. So there is a higher probability of a higher, say, taxpayer satisfaction, because instead of going through each of those files manually and then verifying them and asking for more information about each of the expenses being claimed, right? So this kind of automation, if it can be brought in, then this definitely brings in little more transparency and improves the satisfaction levels of taxpayers, okay? And then it also helps in improving the efficiency of the tax department people. Now that we have come to the end of the demo on the tax filing use case, I would like to quickly highlight some of the key features of Oracle Analytics Cloud. Now, as part of the demo, we have seen some of these features be around data visualization or machine learning model building, but Oracle Analytics Cloud actually comes with a rich set of visualizations, rich set of functionalities, and I would just like to briefly summarize these key capabilities that Oracle Analytics Cloud platform brings to the table. So Oracle Analytics Cloud platform provides you features for all the three categories of analytics. So be it governed analytics, self-service analytics, or augmented analytics. So by governed analytics, what we mean is these are those enterprise-wide used reports and dashboards that are built on top of a semantic model, and the data usually comes from a data warehouse. Okay. So now the access to these reports and dashboards are usually given based on the roles of the users within an organization, and also the data level access that each of these users would have. So you can define even role-based access and data level security rules as part of the governed analytics. We also have a component called as publisher, which can be used to build pixel perfect reports. So by pixel perfect reports, what I mean is that if you have some reports which are like statements, say you have a company logo and then maybe the address of the company and then certain text in a specified format and then the data about a particular account or customer, right? So these kind of reports, like say a bank statement, can easily be generated using the component called as publisher. Now coming to self-service analytics, self-service analytics is a category where what the analytics platform provides as features to, say, an analyst or a power user. Now, typically a business analyst or a power user would have access to the data warehouse or the reporting system from which they get data and they can build the reports and dashboards. But because of the nature of their job, they even might have access to, say, other data sources within the organization. And in some cases, they might also have to bring in some third-party data. So now Oracle Analytics Cloud makes it very easy for these analysts to upload these new data sets or connect to those data sets residing in some data sources within the organization, bring it into the analytics platform, combine it with the existing maybe data warehouse data, blend it, create curated data sets, or use the data from different data sources to come up with new insights or maybe address the questions that they have at hand. So as part of self-service analytics, we have rich capabilities around data visualization. Around 50 plus visualizations are supported out of the box. And we have capabilities around data preparation. And coming to augmented analytics. So augmented analytics is all about the AI and ML capabilities that the platform provides to its users. Now Oracle Analytics Cloud provides capabilities around machine learning model building, which you have seen as part of the demo as well. So it's a very easy to use UI where without having to write complex codes or SQLs, you can easily build the machine learning model just using a easy to use drag and drop UI. Now, apart from that, we also have some advanced analytic functions such as explain and auto insights. We also have capabilities around data enrichment. Say you have a data set in a file, or you are getting data set from a new data source where maybe there is not much of information available about that particular data set, right? So once you upload this data set into the system would do deep data profiling and provide you statistics about the data set at column level. Okay, and it will also suggest you some enrichment recommendations based on the data. And once data enrichment is done, if you have that data set now that it is enriched, right, prepared and enriched, you can also use the capability of auto insights, where the system would do semantic analysis and actually generate visualizations based on the data set that is uploaded and give you some new insights about the data. Now, each of the visualization that gets generated as part of the data enrichment also comes with a description. Now, again, Oracle Analytics Cloud also has the capability around natural language generation. So say for a particular visualization, you want to have a description of the visualization, you can use a visualization type called as narrative view. So using a narrative view, you can actually generate a description of a particular visualization as well. Now, with all of these rich set of capabilities, Oracle Analytics Cloud Platform caters to all of the different personas that you see in an enterprise. So be it business users who are used to seeing maybe the standard reports and dashboards, to business analysts who would like to do a lot of build new analysis, bring in additional data, come up with new insights, or maybe try to find answers to questions that they have at hand. To citizen data scientists, where they can easily build a machine learning model. So these citizen data scientists usually would have very good knowledge of the domain, the data, but then without having to write any SQL or code, they can easily build a machine learning model. So this way they can actually ask better questions. Finally, to data engineers, where we have capability of data flow, where they can use to create curated data sets, okay, do some data profiling and all of these things. So as you can see, Oracle Analytics Cloud is a complete platform providing capabilities around a wide spectrum of analytics requirements. Thank you for attending. Thank you.